Being the convener of the e-national conference on the innovative research in the electronics and telecommunication, I would like to call Dr. Professor Vikas Gupta sir, who is the head of department in the electronics and communication department, and which is working as a professor as well as head and director in charge in the Technocrat Institute of Science and Technology, Bhopal. So I would like to call his father giving the session. So whatever the brief biodata which is given by which is described by the Professor V.K. Barbudde sir. So I would like to call the Professor V.K. Barbudde sir to give the brief descriptions about the Dr. Professor Vikas Gupta sir.
Good afternoon all. Myself Professor V.K. Barbudde. I will give brief description about Dr. Vikas Gupta sir, education and qualification. So Dr. Vikas Gupta sir, working as a professor and head of department of electronics and communication at Technocrat Institute of Technology, Bhopal. He present a paper in conferences and journal more than 55. Then PhD and MTech project guided, that will be MTech for 82 students and PhD for 2 students. He guides. Then reviewer, he acts as a reviewer in elsewhere journals, IET journals, IEEE Access journals. Then he working as a head of department in electronics and telecommunication department, and he published more than 10 books on electronics and telecommunication engineering. So I would like to invite Dr. Gupta sir for continue his session. Hello.
Yes.
Okay, sir. Start your session, sir.
So should I start?
Yes, sir. Yes, sir.
Yes. Somehow I am not able to start my video. So I should start with audio only.
Yes, sir. Yes, sir.
Okay. So good afternoon all. I'm Vikas Gupta, Professor and Head Department of Electronics and Communication Engineering, Technocrat Institute of Technology, Bhopal. I'm thankful to Dr. Anirudh D. Shilotkar, convener of the conference and head of the department, Electronics and Telecommunication, Jagdamba College of Engineering and Technology, Yavatmal, to invite me as a keynote speaker in this National E-Conference on Innovative Research in Electronics and Telecommunication 2020, NCI-RET 2020, on 15th May 2020, organized by Electronics and Telecommunication Engineering Department, Jagdamba College of Engineering and Technology, Yavatmal. Today, my topic of keynote presentation is current research trends in electronics and communication engineering. Current recent trends in electronics and communication engineering. The contents of my presentation will be, firstly I'll discuss the current recent trends. After that I'll discuss about the visual information, image processing and computer vision. See, in electronics and communication, the current research is going on in communication engineering, device modeling and signal processing. In communication engineering, research is going on in the field of optical communication. Research is going on in the field of optical communication, communication network and wireless communication. In optical communication, research is going on in design of optical fiber, establishment of optical network and photonic devices are manufactured. In communication network, research is going on in the field of wireless sensor network, antenna design, where design of microstrip antennas operating at high radio frequencies are carried out. And wide research is going on in the field of Internet of Things. In Internet of Things, the interconnection of devices to share or collect data through Internet is done. In wireless communication, research is going on in the field of mobile communication, RF communication, and cognitive radio. In the field of circuit design, research is going on in the field of low power circuit design, where dynamic power reduction is done, static power reduction is conducted, and study of various design techniques is done. In device modeling, nano devices modeling, transistor design modeling, and FinFET devices modeling is done. In algorithm design, front-end design, and optimization techniques are used. Now, in the field of signal processing, research is going on in speech processing, image processing, image processing, and biometric processing. In speech processing, research is going on in the field of speech enhancement, signal security, and compression techniques. In biometric signal processing, research is going on in the field of fingerprint analysis and face recognition. In the field of image processing, research is going on in the field of computer vision and artificial neural network. Today's my topic of discussion will confine to image processing and computer vision. Firstly, I'll discuss the visual information. See, visual information is the most significant way of information processing and interpretation in human brain. 1/3 of the active area of the human brain is dedicated to visual information processing. An image is nothing but the impression of optical energy formed on retina of human eye. It is an artifact that depicts or records visual perception. We can think of an image as a function f, where fxy gives the intensity at position xy. Now I'll talk about the digital image. A digital image is a representation of image in two-dimension array as a finite set of digital values called picture elements or pixels. A digital image is formed by discretizing both spatial coordinates and associated values. A color image is just three functions pasted together as RGB. Vector value function given by RXY, GXY, and VXY. Next, I'll talk about the pixels in an image. Each component in an image called pixels associated with a pixel value. A single number.
Starting.
A single number in case of intensity image or a vector in case of color image. Image resolution. It represents the number of pixels in an image. Higher the number of pixels results in larger image size and better image quality. As given in this diagram also, as the number of pixels increases, the image quality increases. The image quality for the pixels 256 cross 256 is far better as compared to the pixels value 32 cross 32. This is all about the image resolution. Now I'll talk about the color depth. It is the number of bits required to represent intensity at any pixel in the image. Higher the number of quantization levels leads to higher color depth. If the color depth of an image is n, then total number of colors in the image is m, where m is equal to 2 raised to the power n. The image of color depth n could contain colors ranging from 0 to m-1. See, this is the effect of quantization levels. This is first image representing 256 quantization levels. So as the number of quantization levels decreases, the quality of image decreases. It will be more blurred as the number of quantization levels decreases. Now I'll talk about the image formation. These are the steps involved in the image formation. Firstly, an image is sensed by sensing the behavior of the scene, then define the image resolution in terms of image size. After that, color depth is defined in terms of the quantization levels. Now, sense the value of detected signal at every pixel, represent the captured signal in the defined image plane as numerical value. This gives the digital image. After this, the processing of the image and its analysis is done. Image processing basically confined to these three different categories as image enhancement, image compression, and image segmentation. Firstly, I'll talk about the different fundamental steps in digital image processing. Firstly, a low-level processing is done using pre-processing steps and the image acquisition. See, image acquisition is a very important step in the digital image processing. In intermediate level processing, image segmentation, representation, and description is done, again on the basis of the knowledge base. The output of the intermediate processing is applied to the high level processing, where image recognition and analysis is done to get the desired result. These are the steps of image enhancement. Image enhancement consists of point operation, special operation, transform operation, and pseudo coloring. In point operation, contrast stretching, noise clipping, window slicing, and histogram modeling is done. In special operation, noise smoothing, median filtering, unshaped masking, low pass, band pass, and high pass filtering is done, along with zooming is done in special operation. Now I'll talk about the transform operation. In transform operation, linear filtering, root filtering, homomorphic filtering is done. In pseudo coloring, false coloring and pseudo coloring is done. This is all about the image enhancement. These are the two images which shows the shadow removal. See, in the first and the second image, there is a removal of shadow. There is a shadow removal in the lower side image as compared to the higher side image. This is the pseudo coloring. Pseudo coloring, these days pseudo coloring is going on. You are getting the old black and white movies are converted into colored using pseudo coloring. Now I'll talk about the image restoration. Here in image restoration, the removal of noise from the image is done. See, noise are of two types. Basically, it is fixed value impulse noise or random valued impulse noise. Fixed value impulse noise is also known as the salt and pepper noise. And random valued impulse noise is removed from the image using filter domain and the transform domain. In filter domain, various filters are used to remove noise like peak filter, median filter, adaptive mean filter. And this is sometimes also known as the noise degradation, image degradation. Degradation comes in many forms such as motion blur, sensor noise, camera misfocus, relative object camera motion, random atmosphere turbulence, and so on. Now I'll talk about the image restoration. Image restoration consists of key discussions as restoration models, linear model, and other model. In restoration model, image formation model, detector and recorder. Image formation model, detector and recorder, noise model, and sampled observation model is there in restoration model. In linear filtering, invert, pseudo-invert filter, linear filter, FIR filter, generated linear filter, spline interpolation, and smoothing is done. Least square and SPD methods are there. Recursive, known as Kalman filter, is used. Semi-recursive filters are also used in linear filtering. Next, I'll talk about the other methods like speckle noise reduction, maximum entropy restoration, Bayesian method, coordinate transformation and geometric correction, blind deconvolution, and extrapolation. These all are the other methods. These are the transform-based methods used in image restoration. This is the diagram which is representing the use of non-linear filter known as the median filter in order to remove the salt and pepper noise. See, first image is the original image. It is being corrupted by salt and pepper noise, and the median filtered image is given in the last picture. This is all about the image restoration, and now I'll talk about the image compression. See, image is compressed. Normally it is compressed, and just to have the storage reduce the storage capacity. The size of the data associated with visual information is so large, image data becomes very significant. Therefore, providing adequate transmission and storage space is a challenge in the design of image processing systems. The amount of image formation that is handled by system is growing exponentially. Hence, these issues are also increasing even at higher pace. To convey same amount of image data with lesser size, these are the techniques which are cumulatively addressed as image compression. The amount of compression achieved is governed by the existence of redundancy in image data. They are broadly classified in two categories as lossless image compression method and lossy compression methods. Now I'll talk about the image segmentation. Image segmentation divides an image into a sections that possess some sort of similarity within the region and some difference between adjacent regions. There are fundamentally two kinds of approaches to segmentation, as discontinuity approach and the similarity approach. Similarity may be due to pixel intensity, color or texture, and discontinuity are sudden changes in any of these, but especially sudden change in intensity along the boundary line, which is called an edge. Normally, edge is a very important consideration whenever we are checking the discontinuities. It partitions a digital image into multiple segments. The goal is usually to find individual objects, regions, boundary of interest in an image. Segmentation is done to simplify or change the representation of image into something that is more meaningful and easier to analyze. Three major ways are thresholding, discontinuity-based segmentation, and region-based segmentation. This is an example which is representing the segmentation as edge segmentation and region segmentation. In the first diagram, you are able to clearly visualize the edge segmentation, and in the second diagram, the region is being segmented. Now these are the different applications of image processing as medical imaging. See, image processing is generally these days useful in medical imaging like MRI image and brain tumor detection. Locate objects in the satellite images. Satellite communication also use image processing techniques. Face recognition. In face recognition, image processing techniques are used. Fingerprint recognition, traffic control system, pattern recognition. See, pattern recognition, machine learning and computer vision, they are not able to work without image processing. And these are the very important integrated part of image processing as pattern recognition, machine learning and computer vision. So in the next discussion, I am going to discuss this only: pattern recognition, machine learning and computer vision. See, computer vision, it is a retrieving visual data from image, useful data from image. We are going to discuss pattern recognition, machine learning and artificial neural network. In pattern recognition, I am going to discuss pattern representation and pattern recognition. So firstly, I'll discuss what is pattern. See, pattern is everything around in this digital world. Pattern can either be seen physically or it can be observed mathematically by applying algorithm. It is vaguely defined that could be given a name. For example, pattern could be a fingerprint images, a handwritten, a human face. Pattern is represented by a set of D features or attributes viewed as D-dimension feature vectors. Pattern recognition. Pattern recognition is a process of recognizing patterns. It is a research area in which patterns in data are found, recognized, and discovered. It has a very wide application domain which are mostly used for automated systems. It is a study of data based on knowledge already gained or on statistical information extracted from patterns or their representation. These are the components of the pattern recognition. Yes? Now I'll discuss the components of pattern recognition system. Component of pattern recognition system. The basic pattern recognition system contains a sensor like cameras, also known as measuring devices. After that, pre-processing is done in terms of noise filtering, feature restriction and normalization. After that, classification algorithm is applied like regression, clustering and description. Lastly, model selection is done in terms of cross-validation and bootstrapping to get analysis result. Now I'll talk about the machine learning. Machine learning, according to Tom Mitchell in 1998, learning is any process by which system improves performance from experience. Machine learning is a study of algorithm that improves their performance at some task with experience. That means a well-defined learning task is given by PTE. P means performance, T means at some task, and E means with some experience. Means, in short, machine learning is always use the past data to past experience to improve the system performance. Machine learning is concerned with the design and development of algorithms that allow computers to change behavior based on data, such as from sensor data or databases. A major focus of machine learning research is to automatically learn to recognize complex patterns and make intelligent decisions based on data. Now I'll talk about the artificial neural network. Artificial neural network, it is totally based on our human brain. Brain contains neurons, which are like organic switches. They can change their output state depending on the strength of their electrical or chemical input. The neural network is in a person's brain is a hugely interconnected network of neurons. There is a big interconnection of neurons in our human brain. The output of any given neuron may be the input to thousands of other neurons. Learning occurs by repeatedly activating certain neural connections over others and reinforces those connections. This makes them more likely to produce a desired outcome for specified input. Artificial neural network may be defined as a software implementation of neuronal structure of our brains. They can be trained in supervised or unsupervised manner. Artificial neural network provide a practical method for learning as real valued functions, discrete values function, and vector valued functions. Basic model of ANN, that is artificial neural network, it consists of interconnections. Basically, in artificial neural network, there is a big interconnection. Some learning rules are used using some activation functions. Generally, activation functions used are step functions, sigmoid functions, and the linear functions. Typical activation functions works as follows, like for summation I is equal to 1 to n wi xi. So each length I has a weight wi associated with it. The input to node I is xi and t is the threshold. So if the weighted sum of the input to the neuron is above the threshold, then the neuron fires. This is the diagram of an artificial neural network. Multi-layer artificial neural network. It is consisting of 3 input layers, 2 output layers, and 5 hidden layers. Unidirectional information flow is there, and data is always firstly presented to the input layer. It is passed on to the hidden layer, and finally going to the output layer. Information is distributed, and information processing is always parallel. Okay? So this is all about the discussion which I want to do, and this is the diagram which is representing the interconnection of machine vision, image processing, and computer vision. There is a big interconnection between the machine vision, computer vision, and image processing. And these are the different research areas where the work is going on. As in computer vision, we are having the machine learning, cognitive vision, artificial intelligence, and computational intelligence. And it is also using some part of machine vision as automatic control robotics and signal processing. Some part of optics is also used in machine vision. Image processing is also useful in machine vision because image processing is required to have the smart camera and imaging technologies. Some biological vision and neurobiology is used in image processing. and the statistics, geometry, optimization, and mathematics is used in order to go with all these techniques used in computer vision, machine vision, and image processing. So, with the discussion of this all, like image processing, computer vision, I am going to discuss the applications of this all, as this computer vision, image processing, machine learning is very useful in robotics. Robotics these days, robotics is a very important role in our wide digital world, where different machine learning techniques are used in order to design these robots. Medical imaging. See, medical imaging, image processing is very useful these days. In medical imaging, brain tumor is detected as stage 1 brain tumor, stage 2 brain tumor is detected using medical imaging. MRI, medical resonance imaging is done using image processing. So medical imaging is using these different techniques widely. Digital cosmetics. These days, digital cosmetics is having a very big market. So it is this image processing is very useful in digital cosmetics. Deblurring. At times the data is blurred, and in order to have the deblurred data, we are using the image processing technique in order to remove the blurring in the images, because at times we are interested to have the good data, to have the deblurred data. In fact, in medical imaging also, at times we are requiring to decrease the blurring in the images. There we are using the image processing techniques. So this is all about my presentation today. So if you are having any query or question, you people can ask.